So in this video, what we're going to talk about is how an animal decides what to eat. And so that will be the big question. And we'll talk a little bit more about optimum. Um, um, I just blanked. That's funny. Optimal foraging theory. All right, so let's look at what we'll be looking at. So foraging decisions, energy intake. How much energy am I going to get on each of the things I eat? Encounter rates with each item. How long is it going to take me to find one of these prey items? So when I do attack, is it going to take me, 5 seconds to catch it? Is it going to take me an hour to track it down? Like a cheetah, they run pretty quick, and they're gonna get it in the first 20, 30 seconds at best. Whereas African hunting dogs, it's going to take longer. Search time. How long is it going to take me to actually just search these animals out, the prey items? And then once I catch it, how much handling time is that going to take? So all of these things are important questions. So this is a very famous study. So I want you to know this one real well. This is the optimal foraging theory by Retro Zach. And he worked on northwestern crows, bird on the bottom left, and they eat whelks, which is a gastropod similar to snails. And the problem is they need to crack these suckers open. So it turns out the larger ones are actually easier to break into than the smaller ones, but there's issues. So what these animals do, what the crows actually do, is they will take a whelk, they will fly up into the air, and they will drop the whelk on the ground, trying to crack it open so it can get to the meat, to this the animal inside. So it turns out they did this big study to find out what size whelk they were using, and then again, also how high would they have to fly? Well, it turns out if you look here, number of drops per whelk, we have the small, the medium, and the large whelks. And so it turned out the best height for dropping whelks, if you can see here, is the number of drops. So what you're trying to look at is when does it kind of level off? And it turns out for the larger whelks, the best is right around 5 meters. And that would get you the fewest drops. You might have to do 2 or 3 drops. Okay, so this was kind of a trial and everything. A lot of the young crows, that might be true with trial and error. They're watching other crows, and the crows are very smart, so I'm sure there's some learning processes in there. But it turns out, so that's what we want you to know. For a northwestern crow, the best thing to do is grab a large whelk because they're the easiest to break. And then it would be to drop it from 5 meters high, and you're going to drop it a couple of times, 2 or 3 times probably before it cracks open. But what you can see is that if you don't drop it from far enough, you're going to have to drop it lots and lots more times. And if you do a smaller whelk to break it, you're going to have to go up higher. And that's probably not a good idea either. So anyway, so that's very famous early study on this optimal foraging theory. All right, oyster catchers, another bird, and on the right is actually a mussel, not an oyster, but related. And same deal. They're trying to open it. These guys aren't the droppers, but what they had to look at is lots of different mussels are available. So what do? What size do you go after? It turns out the large ones are too hard for them. They can't. There's a muscle inside the mussel, if that makes sense, that actually holds them shut. And oyster catchers cannot get the big ones open, so they will leave those alone. And then the one next size down, which they can actually open, they have barnacles on them. And barnacles are little arthropods that are on the outside. and it makes it a little more difficult also to open. So it turns out the ones that have probably the best chances of actually feeding you are in from the 30 to 45 range. So you can see this is where the mussels are selected. But you can also see that that's not necessarily the ones that are they're present. Okay, so if you look at here, you'd think, well, I'm going to eat the 45 and above, and I'm going to eat the really small ones. Well, the really small ones don't give you enough food, and then the really big ones on the end are too big to manipulate, or they have barnacles. So this is the best size, and these animals learn that fairly quickly. And what might be keeping down the number is the fact that these guys are preying on that one group. And then this is just a bunch of mussels and how they're found. So these guys will kind of wander around looking for the right size. All right. Another example of this would be the European starlings. This is a introduced bird here in the United States, and it's here in Southern California. And they eat yellow jacket larvae. That's the main component of their diet. And so what happens is they go out to get them to bring back to their young. And so what's the problem with this is they can go out and catch one, bring it back. That's fine. And or do they go collect a bunch and bring them back? And that becomes the problem. So what I want you to kind of get the idea about is that there's travel time. So travel time is an important concept because I don't want to travel back and forth. If you think about it, you're home and you need something, you might run to the store real quick and grab one item. That's fine if the store is a mile away. But if the store is actually 30 miles away, you start to contemplate, well, do I really need that item that bad? Do I drive out for it? And then if I'm going to drive out for it, do I just grab that one item? Maybe I should do some shopping. Maybe I should look around and pick up 10 to 15 items. Okay, but the problem with these birds is they're going to have to carry it back. So as you add more and more items to your beak, it becomes harder and harder to deal with it. That becomes what we call handling time. How long does it take me to rearrange all those larvae in my mouth so I'm holding on to it? I'm not going to, if I drop it, do I go get it? So that is a constraint. So they were looking at what's kind of the best ratio, and it turns out for them 7 was the best. Lower than 7 meant they're wasting time. That travel time going back and forth, they're not optimizing it. But trying for 8 or 9 prey, the handling time, you just lose some benefits on the other end. All right, and then the last one is the great tits. This is a European bird, and Krebs did an experiment in '78 on these. And so they were looking at how you dealt with foraging. And so what they were doing is introducing a couple of different items to them. And trying to figure out which ones they would choose. So there's a conveyor belt. They're in this little box, and the conveyor belt goes by, and there's mealworms there. And so there's large mealworms and small mealworms. And so what they would do is what they finally figured out is they ran the conveyor belt, and you can see there's different trials. And what happened was, as long as they prefer the larger prey, you get more food from that. And so they would pretty much, if there was lots of large prey available, they would ignore the small prey. It wasn't worth the effort. But what they did find is that as long as there was profitable prey, they would not go after necessarily the smaller prey, even if the smaller prey was more. In other words, they had a lot of smaller prey, but if you had enough large prey going by, they would just wait for the large prey. Wasn't worth their time, even though there was a ton of them. It wasn't worth their time going down and picking that up. So then again, foraging theory and what you should do or not do. So.